Here is the second example using decibels this time. So at around 130 decibels, the human eardrum can be severely damaged. And after 135 decibels, permanent hearing loss is almost a guarantee. So first thing we have to find is the values of the sound intensities in watts per square meter. And secondly, we have to do this little proof that, well, we have to find the ratio of the intensities of the sounds and show that all 5 decibel gaps actually have that same ratio. So you can go ahead and try this problem, and then when you're ready, you can come back for the solution. This is a slightly tougher problem, because obviously we're going to have to bring in base 10 logarithms. But one thing we'll actually start by doing is organize the work so that we only have to do one sum in. So if we rearrange beforehand, that's going to help us a lot. So we'll get beta is 10 times the base 10 logarithm of I divided by I0 as a constant, so 1 times 10 to the minus 12. So we'll just get an equivalence for I. Now I'll quickly, I won't necessarily do the algebra here, but you can do it yourself. It should get you 1 times 10 to the minus 12 times 10 to the power of beta divided by 10 as the intensity. So when subbing that in, if we're given beta is 130 and beta as 135, I've already worked these out. So this one, I1, is actually 10 watts per meter squared, and then I2 is 31.6 watts per meter squared. So those are the two sound intensities, 10 and about 31.6. Now the second part is to find the ratio of the intensity, so that's actually part 1. Now part 2, so the ratio of the intensity, so the ratio is just going to be 31.6 over 10, so that's 3.16. And all you have to do to show this is just sort of define a new variable. So we'll just let this sort of sound intensity at some point be alpha. So at the second point, it's going to be alpha plus 5, both in decibels. So what we'll get here after the fact is I2 divided by I1 is, if you substitute both of these in, the top will be a 1 times 10 to the minus 12 times 10 to the power of alpha plus 5 over 10 divided by another 1 times 10 to the minus 12 times 10 to the alpha over 10. Now these will both cancel, the 1 times 10 to the minus 12s. And then what we'll get is 10 to the alpha plus 5 over 10 to the alpha over 10. And from there, because we have dividing powers that have the same base, we can just subtract the powers. So we'll get alpha over 10 will cancel with an alpha over 10. And then we're left at 5 over 10, which is just 1/2. So the ratio is actually 10 to the power of a half, or the square root of 10. Now we can see this in this particular example, because the square root of 10 tends to be about 3.16. So that is going to be the constant ratio. If it keeps going up by 5 decibels, it will increase by a factor of the square root of 10 each time. And we can see that this is not dependent on alpha, so it works for any base, sort of any starting point of decibels. If you want to go up by 5, the intensity in watts per meter squared increases by a factor of the square root of 10.